All right, in our next video for 14.3, we are going to use those same identities we used in the last video, but this time we're going to be doing some simplifying and verifying. So just to get going here, what I'm going to do is write our main Pythagorean identity at the top here, just as a reminder, because I don't have my other sheet in front of me. Just as a reminder of the main one that we use. The other ones that we use are based off of things that we've kind of used before. And then remember how we got the other two was we either divided this one by cosine squared, which would give us 1 plus tangent squared equals 1 over cosine squared would be secant squared, or we divided each term by sine squared, which would give us cotangent squared plus 1 equals 1 over sine is cosecant, so it would be cosecant squared. And we have other forms that these things can come in, being solved for different pieces than what they are right now, but that at least gives us something to kind of refer back to. All right, so here are some general hints on both simplifying and verifying. Verifying, here's a little definition, is to algebraically manipulate one side of the expression until it is identical to the other side. And if you look down here, we're given these 4 problems to do. So what we're saying is we're going to change one side of the expression until we get it to become the other side. So this is usually referred to as the left-hand side and the right-hand side, or LHS and RHS. Oops. So we're going to try to prove that one equals the other. We will always start by writing one of the sides. In each of these problems, we are going to start with the left-hand side and then work to the right-hand side. We'll get to those in a second. So the reason why I showed you these first is because we know what we're looking for in these. We want that to be our final answer. We want that one to be our final answer. In these simplifying ones, we're just asked to simplify, and we don't know what the final answer is going to be. We just need to use our identities to simplify the expression, along with some other algebra tricks that we've learned in the past. Here are a few other general hints. Writing all the functions in terms of sine and cosine is usually helpful because every trig function can be written in terms of sine and cosine. So if we can do that, sometimes we get things to combine or cancel out. We're going to combine expressions together using an LCD, so that's going to be useful when we have 2 or more expressions and we want it to become one expression. For example, as I look down here, that might be an appropriate thing to do in that problem because there's 2 things on that side, 2 terms, 1, 2, and there's only 1 term on that side. So I think an LCD might be appropriate in example 9 coming up. Factoring. It says, remember all the patterns you've learned, especially the difference of squares. A squared minus b squared. I'll just write it over here. The fact that a squared minus b squared factors to cosine squared minus sine squared. I'm sorry, that a squared minus b squared factors to a plus b times a minus b. I was getting ahead of myself there. And we can use that to factor something like cosine squared minus sine squared. Call that cosine plus sine, cosine minus sine. Don't forget that factoring, a big idea of factoring is the first step is to always pull out a GCF. So GCF is going to be a huge part of what we do too. And then the last thing we're going to do is, or the last thing that we could try is maybe some distribution or foiling. This may lead to the square of a function, so you can use the Pythagorean identities. All right, let's try a few problems here. So we have tangent of pi over 2 minus theta. That should look familiar to you. That was one of our cofunction identities. Here it is. So we know that tangent of pi over 2 minus theta equals cotangent. So what I'm going to do is just simply replace it with cotangent. There's nothing else you really need to write there. You just replace it with what it's equal to. Okay, it already looks simpler, but there's more we can do. We can call that cotangent cosine over sine. I'm just bringing that sine of theta down for the ride here. And then lastly, we notice that sine of theta, since that's over 1 and is in the numerator, can cancel out that guy. And our final answer here is cosine of theta. So this original function actually equals just cosine of theta. In the next problem, example 4, everything's already in terms of cosine and sine, so I think our best bet here is to pull out a GCF. If we pull out that cosine of theta, we'd be left with 1 minus the sine of theta squared. So that cosine of theta, I'm just going to leave alone. This guy is the same thing as cosine squared. I don't have it written up here. It's in one of the other forms, but hopefully you recognize that 1 minus sine squared is the same thing as cosine squared from our Pythagorean identities. 1 minus cosine squared would be sine squared. 1 minus sine squared is cosine squared. So our final answer here is just by multiplying those two together, which would give us cosine cubed. And our last problem here, mine got chopped off. That should be a sine of theta. There's no GCF to pull out right now. I guess there could be. We could turn this into, that into cosecant and then pull that out. I'm going to do this a little bit different way though. I'm going to change everything into terms of sine and cosine. So I'm going to call that 1 over sine. Cotangent squared, I'm going to call cosine over sine, both squared. And I'm going to leave that as 1 over the sine of theta. Okay, and I'm going to multiply these first two factors together. That would give us cosine squared over sine cubed. And there's other ways that we could have done this. Like I said, we could have turned that into cosecant right away and pulled that out as a GCF. In fact, I might follow up by just showing you what that would look like. The reason why I chose this route is this is now going to use one of the other hints that we have up here, and that's number 2's hint, which is to combine expressions using an LCD. If you notice, this guy is already sine cubed. This guy is sine. If we multiply that right expression by sine squared over sine squared, which is totally legal to do because it's equal to 1, so we're not changing anything, that would give us a common denominator. And I'm starting to run out of room here, so I'm just going to come over here a little bit. We'd have cosine squared over sine cubed. We're going to add, looks like sine, what I would get here is sine squared over sine cubed. So I have a like denominator now. And I can combine those together. I get cosine squared plus sine squared. And hopefully as soon as you write that, you recognize where we're headed with this. We have 1 over sine cubed. And we do want to finish these without having any fractions if possible. So we're going to rewrite this as this 1 over sine cubed. Since it's 1 over sine times itself 3 times, that's the same thing as taking cosecant times itself 3 times. So that's what we're going to write as our final answer there. Okay, a little bit more, little more steps than the previous ones. Show you what I was talking about originally. Another way that you could have done this problem is to recognize that last term could be rewritten as cosecant, 1 over sine, and then pull a cosecant out as a GCF. It's common to both terms. That would leave me with cotangent squared plus 1. And you're probably wondering, why didn't we do this right away? This looks way easier. Maybe you see where this is headed already. Cotangent squared plus 1. Look at that. That equals cosecant squared. So we can replace that with cosecant squared. And you don't have to do all this like underlining stuff. I just do it so that you can kind of see what's being replaced where. Make that a little bit nicer. So our final answer here is going to be the same thing that we got previously. That when I multiply those two things together, I get cosecant cubed. But I did it the first way so that we had one problem where we were trying to get an LCD, a lowest common denominator of sine cubed, and then we could combine those two fractions together. So that's simplifying. I actually think that verifying is a little bit easier because you know where you're headed. With simplifying, you're just trying to make it look simpler. But with verifying, you know what you're trying to get to. So in example 6, we want to make our left-hand side become this right-hand side here. Now, my one thing that I ask you to do is just start with one of the sides, usually the more complicated side. I almost always start with the left-hand side. It usually works well in most of the problems that we're given. But my request to you is that you start by rewriting that left-hand side. That should always be your first step. Or I guess if you do start with the right-hand side, but rewrite whatever side you're starting with. Because what we want this to look like is the original problem with a bunch of stuff in between. We're going to do a bunch of work here, and then we're going to end up with our last step is going to look like this. So it kind of shows how you go from one to the other. Now we just need to figure out what goes in between there. Okay, and I might need to move that thing in a second when we get to the end here. So as you look at this, cotangent squared, a couple different routes that we could go with this. I see that cotangent squared, and I know that I can replace that with using this identity, cosecant squared minus 1, if I bring that 1 over there. So if I do that, or I guess the reason that would be, oops, we're using x's here, beneficial, okay, because there's other things that we could do here, but the reason why I chose that is because I see subtraction on my right-hand side. And I know by bringing subtraction to the problem, that's getting me one step closer to where I want to be. Then what I see is this. I'm going to come down here, because I can tell that we're almost done with this problem here, actually. See that I can separate that, kind of like we do with quadratic equation answers. Separate that, and then we'll simplify. So each denominator would have that cosecant of x as its denominator, and I just separated that into two separate fractions. Well, 1 over cosecant of x, well, first of all, let's take this one step at a time. One of those cosecants cancels out with that one down there, and I'm left with that cosecant right there. And then the next thing I notice here, and I'm just going to show that my step here, is that 1 over cosecant of x, well, cosecant of x is 1 over the sine of x. So I'm making sure to use my identities. Yeah, I know that you could say, oh, the reciprocal of cosecant is sine. And in some of our longer problems, I might just allow you guys to do that. But for right now, yeah, this is not one of our longer problems. For right now, let's take our time and use our identities. 1 over the sine of x becomes just simply, because we're taking 1 times the reciprocal of that denominator. The reciprocal of that denominator is just sine of x, and then I finally get that right-hand side. And like I said, in a longer problem, we may be able to just go right to here, but I don't think it's a bad idea in the beginning here to start using our identities as much as we can. All right, in our next problem here, we are looking to get this thing simplified to simply cosine squared. So let's start by rewriting that entire left-hand side. Okay, I'm not going to do anything in my first step, but just rewrite it, because as I rewrite it, I'm starting to think of what I can do. Well, 1 plus tangent squared, that looks pretty familiar. As one of our Pythagorean identities, that's equal to secant squared. So I'll just replace that. And maybe that's not the thing to do, but it looks like it might not be a bad thing, because I don't have any addition or subtraction in my right-hand side, and that got rid of it. I know that cosecant, oops, one second here, trying to show what I did with some colors. Well, there we go. I know that secant, is the reciprocal of sine, so I'm going to replace the secant of x with 1 over, I think I said sine, I meant cosine, with 1 over cosine. So I've replaced those two things that I have colored in red and blue there. Well, now cosine times 1 over cosine, that just equals 1. And my denominator is secant squared. Well, secant squared, I know, is 1 over cosine squared. So this is very similar to what we just had happen in our last problem. I'm going to call this the numerator times the reciprocal of the denominator. The reciprocal of the denominator is just cosine squared. So that's my final answer. And as you go through the problem, be cognizant of what you're looking to get to. We're trying to get the cosine squared. As we were going through this, I saw we were getting rid of like the tangent and just having cosine squared as part of or cosine as our only function. So I kind of knew we were headed in the right direction. All right, two more here. This next one, maybe start with the left-hand side on this one. There are other ways you can do this problem, but I want to show you this little trick because it should remind you of something we've done in the past. Okay, so this is definitely outside of what we've done so far on these first couple problems. We are going to multiply the fraction that we're given, that left-hand side, by 1. Obviously, it's going to be a funky-looking 1. If you remember multiplying by conjugates, both irrational numbers, like 3 minus the square root of 2, we would have multiplied by 3 plus the square root of 2 to get rid of it in the denominator. Or we also did it with imaginary numbers when we did imaginary number division, complex number division. We're going to multiply this by 1 plus the cosine of x, the conjugate of that denominator, over itself. And the reason why, and I actually did put this in a hint in the notes up here, to distribute or FOIL, except we had to come up with what we were FOILing, because we're going to come up with the Pythagorean identity here. So in the denominator, 1 minus cosine, 1 plus cosine, that becomes 1 minus cosine squared. And in the numerator, I see sine times 1 plus cosine of x. Well, before you go distributing, what I'd like you to do is look up at the right-hand side, where we're trying to get to here. It has 1 plus cosine in it. So I don't want to distribute that, in other words. I want to leave that as sine times 1 plus cosine. And if you did distribute, that's fine. You can just pull it out later on. But I want to leave it like that because I want this to be a part of my final problem, or my final expression. Now the denominator, 1 minus cosine squared, we know becomes sine squared. That's nice. Look at what's in our denominator on our right-hand side. So we're getting closer to that. And hopefully you see kind of what's going to happen here. We have the sine of x here, and we have that 1 plus cosine of x. And we can cancel out one of our sine of x with that sine, with a sine of x down there. And we're left with our right-hand side. The more of these you do, the more you see kind of what steps need to be taken. And if at any time you want to, pause and rewind and go and kind of think about one of these back through again, or before I do a problem, pause it and think, okay, what could happen here? I think that's a good idea. All right, last one here. I'm not going to start with the right-hand side here and multiply by the conjugate, but I could. That'd probably get us to this left-hand side, to start with the right-hand side here. But I want to show you some different methods here. So we're going to start with the left-hand side and try to get to that right-hand side, kind of the way that we've done so far. This, I think, I see only cosines and sines over here. So I think what we're going to benefit from here is replacing the secant with 1 over cosine and the tangent with sine over cosine, because now I only have sines and cosines. I also only have one term over here, so I think it's going to be a good idea to combine these together. Well, the nice thing is that we already have a common denominator of cosine of x. So in the numerator, I have 1 plus sine of x. Ooh, now as I look up here, we're not really getting anywhere that we need to. But that's okay. Two things you could do here. You could start from scratch, or you could look at what you have and think, how can I get to this with what I'm at right now? Well, I think it's going to involve Pythagorean identities again, except I don't need to multiply by a conjugate here. What I know is if I multiply the denominator by cosine, I'll get cosine squared. And a cosine squared can be factored to 1 plus sine, 1 minus sine. And that has a 1 minus sine in it. So I think that's going to get us to where we want to go. Let's see what happens here. So if we multiply that, we get cosine squared. We get cosine. This is almost going to be identical to what happened in the last problem now, because I'm not going to distribute, because I can cancel one of these cosines out down here with that cosine up in the numerator, and we are now, oh, actually, nope, that'd be bad. I'd be going exactly where I was, so let's not do that. How about we, I lost my train of thought there. How about we call that cosine squared 1 minus sine squared, which is what I talked about before I started tangenting off into some other method, pun intended. The denominator factors using the difference of squares to 1 plus sine, 1 minus sine. There we go. And I'll take a second, look back up at that right-hand side. Look at where we want to go. We're almost there. We want 1 minus sine to be down in the denominator and just a cosine to be up in the numerator. We're there. We cancel those factors out. So we're left with that right-hand side. You should always end by writing that, right-hand side. We always start by writing the left-hand side, if that's what we're starting with, and we always end with the other side, in this case, the right-hand side. So those are some some simplifying and verifying problems using the identities.